All right, everybody, we're ready to start a new unit on atomic theory. And so where we're going to start out is on physical and chemical characteristics of different materials, different elements, different compounds. So to start us off, I'm going to share my screen here because we are going to go right over to chemistry homepage. And as you notice here, I've opened up now a new Bitmoji classroom, atomic theory. The old one, if you still want to review, do more on the quiz, work on your climate change paper, all those sorts of things are still in the old Bitmoji classroom. All right, so I'm going to go to atomic theory, and it brings us to a page that has several assignments built into it. All right, so of these 5 things in here, we're going to start out right now with physical and chemical properties. That is going to open up a new assignment. And this assignment has 7 questions and a little bit of homework for you to do. All right. So I'm going to zip right over to atomic theory notes. So when we think about physical and chemical characteristics, the easiest way to think about that is that physical characteristics, they are the characteristics we can observe without altering the substance. So in other words, I can tell the color of a car by looking at it. I can put the car on a scale and measure its mass. Um, I can smell a substance and tell the odor. Those are all physical characteristics. Chemical characteristics are things that uh, are about the properties of the material. And so another way to think about that is its potential. So in other words, gasoline has the potential to light on fire. Acid, like drain cleaner, has the potential to burn your skin. Um, Alkaline, like we find in alkaline batteries or strong soaps like lye soap, have the potential also to react with our skin and burn our skin. Another reactive substance like that is bleach. All right, so now that we've sort of laid that out for you, number 1 on these notes. So we're going to complete these notes and then go to some questions. All right, so all things are made of matter. That's fundamental to chemistry. Matter is defined as something that has mass and occupies space. So everything in the universe is made of matter. Matter has 2 sets of properties, physical and chemical. We were just talking about some of those. So physical properties of a substance are such things as, give you a minute to think a minute, okay, the smell or odor, its mass, its melting point or boiling point. Okay, those are just some, or its color. So there's 5 different physical properties. Chemical properties are things that are the potential. So flammable, okay, reactive, um, acids, bases. So all of these are chemical properties: acid, base, flammable, corrosive. All of these are different chemical properties. All right, so when we visit this particular website, um, it brings up a little diagram, and I want you to copy the diagram, put it into this Google Doc. This particular website does walk through properties of physical and chemical or physical and chemical properties of substances. So when we think about the properties, you can think about it like a flow diagram. So if we ask ourselves the question, let's say about a car, and I want to know its color, is this property determined without changing the substance? Yes, I can determine the color without messing with the car. Then it's a physical property. Does the property depend on the amount? No, a yellow car is yellow. Okay, so there it is, color. Okay, melting point, boiling point are all things that do not depend on how much I have. If I said, I want to know the mass of an apple, is that physical or chemical? Well, I can determine the mass without changing it. But I go to here and I say, does it depend on how many I have? Yes, it does. Because if I have 1 apple versus 100 apples, the mass is going to change, as are some of these other physical properties. All right, so on the chemical side, I have to change it in order to figure it out. That with gasoline, if I put a match by it, it goes poof, it burns. I've learned something. So reactivity with the air, acids, bases are alkalines. How does it change in water? For example, if I put steel in water, it rusts, and that is a reaction. But if I put aluminum in water, it doesn't rust as quickly. And if I put chromium, like stainless steel, in water, it takes a very long time for it to rust. And things like gold do not change in water. So these are all different chemical properties. So make a copy of that. You could probably do that by taking a screenshot of that little image and then putting it into the document. All right, so I'm gonna go back to the document. Let's look at some questions. Milk turns sour. Okay, we're talking about a process, a change. And so if it is a change, a process, then it's physical or chemical. So a physical change means I could reverse it. A chemical change means I can't. So let's think, the milk turns sour, no, it's changed and I cannot fix it. So it is a chemical change, all right? HCl, hydrochloric acid, being a strong acid. Well, nothing is changing. So being a strong acid, that is a chemical property. Okay, it's a chemical property because it is about how corrosive it is. If I saw a block of wood in half, well, I could reverse that. I could glue the two halves back together again. I haven't changed the wood, but I have changed that it was one and now it's two. So that is a physical change. So physical change and a chemical property. Copper sulfate dissolved in water. Okay, if you think about salt, if I put salt into water and stir it up, you can't see the salt anymore. So then I take my salt water and I put it in a pot on the stove and I heat it up and I boil it and I boil it and I boil it and the steam comes off, which is water. I'm left with the salt in the bottom of the pan. So I can reverse that, even though it dissolves in water. So it is a physical change. We have other physical changes. For example, if I take liquid water and put it in the freezer, it changes to ice, but that's a physical change because it is still water and I can reverse that. All I have to do is get the ice cube out and melt it. Aluminum phosphate has a given density. Well, I'm not talking about any sort of change. I'm just talking about a property. Density, physical, just like melting point and boiling point. So you can find density on our little diagram. Which are examples of matter? A dog, absolutely, has atoms and molecules. Carbon dioxide, yeah, it's also made of matter, carbon and oxygen. Ice cubes, yep, they're made of water, hydrogen and oxygen. Number 4, copper and nitrate. A moving car, all of these are examples of matter. The formation of gas bubbles is a sign of what type of change? This is a really tricky one because it's both chemical and physical. An example is that when you open a soda, carbon dioxide gas bubbles out of it. And that's due to a pressure change. So when the soda pop is under pressure, the carbon dioxide is dissolved in the water. When you open the bottle, the gas is released. So that's a physical change. We're just moving the gas from one spot to another. However, generation of gas is something we also look at for whether a chemical reaction is occurring. So this one could be either one. These true falses, red rising is a physical property. No, bread is rising because yeast is performing a chemical change. Dicing potatoes, yeah, if we just cut up the potato, that's a physical change. Is sunlight matter? It's both. It's matter and it's energy. So that's both true and false. The mass of lead, mass, that automatically tells us it's a physical property. So what you're supposed to do for some homework is go to your kitchen, go to your bathroom, go outside, and find an object and list some physical and chemical properties. By the time you're done, you should have 3 sets of properties, one for each one of those. So that's what we did that first day of our new unit.